So here we have a question where we're told an airplane heads north at 120 meters per second. So it's similar to the last one, but we have different situation. So in this particular case, we're headed north with a magnitude of speed of 120. This time the wind is blowing northeast, so northeast like this. Again, these are 45 and that's 45 as well. With a magnitude of 50. So we're going to draw the interference vector, which is like this, northeast, and that's going to be 50. So that angle there, and that angle there, these two are going to be 45 degrees. We don't need that one, that's going to be 45. And the resultant vector will be, again, from the beginning to the end of the journey that we just took. That's the resultant. So the airplane's headed north, the wind is pushing that way, so it pushes it and it forces it to go at a slight deviation from the original flight course. And we want to know how much that angle of deviation is and how much the velocity is so we can fix it. Now, what we're going to do is we're going to say, okay, let's find this whole angle here because we don't have any angles. We've only got two sides, which is useful. We don't need two sides. We can find a third side, but we need at least one angle inside the triangle. Now, we don't know this one. We're looking for that one in the end. We don't know this one, but we can find this one because we know that's 45, that's 90. 45 plus 90 must be 135. So this angle here is 135. So going back to our equations, now again we're going to start with the cosine rule. So the cosine rule states that v squared, the missing one we're looking for, is equal to the other two squared, so 50 squared plus 120 squared minus 2 multiplied by these two sides here, multiplied by cosine of the angle opposite the V. Opposite the V is 135, and that's why we did it, because we know that angle, we don't know any other angles. Once you plug all these numbers in, you get a value of, don't forget to square root it, 159 meters per second. So in this problem, it actually speeded up the airplane, which makes sense because it's kind of in the same direction as the flow. So 159 meters per second. Now, the second part is going to be sine rule to find this angle here. So again, it's going to be sine of any angle in the triangle. We only know one, so let's use that one. Divide by the opposite number, in this case 159, is equal to sine of the angle that we're looking for, theta, all divided by the side opposite the theta, which is 50. Again, divide that, multiply both sides by 50 and inverse sine, and that gives you an angle of 12.8 degrees.